Now let us see the second example about signed conversions. The problems in C about signed conversions and how Rust has made a design choice to make signed conversions and comparisons safer. In this case, the right hand side is C code and left hand side is Rust code. In the C code, there are two variables. One variable is of type signed integer and another is of type unsigned integer, and they are compared here. So A has a value -1 and B has value 10. A is being compared with B, and if it is lesser, then A less than B is printed. If A is greater than B, then A greater than B is printed. So in this case, since -1 is less than 10, this is expected. A less than B should be printed. Let us see what C prints. So if you run the output, it prints false, right? A greater than B. -1 is actually not greater than 10. So, but this prints A is greater than 10. So, why does C do this? Right? So, why does C print such a wrong value? So, in case of C, whenever there is a comparison between signed and unsigned types, C first converts both the operands to a common type. So what happens? So in this case, it's converting A to from signed type to unsigned type. Let us see how it does that. All negative numbers are represented using 2's complement. So in case of -1, value equal to -1 using 2's complement is represented with all ones. This is a 32-bit signed integer is represented from 0 to 31. All the bits are set to 1. Okay, this is how -1 is stored. But what happens during conversion, during comparison, C does again implicit conversion. So -1, instead of treating this as signed, it simply treats this as unsigned. So it uses the same bit pattern but a different interpretation. So because it's using the same bit pattern and treating this as unsigned, this is the maximum value of unsigned integer, which is this huge number. So what happens in this case? The comparison actually here, if you see, is between A less than B. So A less than B is how much? The comparison is -1 less than 10. But what is happening after conversion? It's comparing this number with 10, right? So this huge number, which is the maximum of unsigned int, is definitely greater than 10, and that's why it prints A greater than B, right? So and resulting in false and wrong result. So Rust prevents this. So let's open only the Rust code here and see what happens in this case. Okay, so in case of Rust, let's only have this block similar to C and then see how this compiles. So now in case of Rust, there are two variable bindings. One is A and B of different types. One is of type signed 32-bit integer and another is of type unsigned 32-bit integer. And similar to C code, there is a comparison of A and B and this is being printed. Let's compile this code and check if this A less than B gets printed in case of Rust. So in case of Rust, it gives a compilation error. It says A is of type signed 32-bit integer, but B is unsigned 32-bit integer. And it also gives a help. It says you can convert U32 to I32. Right? So it basically says both the operands should be of same type and stops the compilation. So what we can do in this case is, let's compile this by uncommenting the second block. So what are we doing here? In this case, we are explicitly marking B, which is unsigned, to signed 32-bit, so that the comparison happens between two same types, signed versus signed. So Rust allows this. And let us now compile this code. Now it correctly prints A is less than B. Right. So this is one of the strongest design choices that Rust has made and improvements that Rust has brought about. Rust treats numeric conversions as potentially unsafe operations. That's why it basically requires all the programmers to explicitly cast it. So otherwise the compiler reports a type mismatch and the programmer has to make an explicit conversion. Okay, so because of this, what happens? That this design basically has eliminated an entire class of bugs caused by implicit conversions and signed and unsigned comparison bugs. Right? So these issues basically are very common in C and C++ code, but Rust making a design choice of explicitly requiring conversions and also making both the operands of same type, it basically all the runtime bugs are shifted to compile time for resolution, and the results are very accurate and precision is obtained.